Okay, good morning. Well, you don't know if it's morning or afternoon. Here's, I'll call it part three of chapter 8, section 1. And so I put this chapter and section into 3 parts because it seemed to be 3 different concepts. And this last one, which is creating a probability dot plot. And sometimes we call it a probability density plot. So in doing so, before we get started, I want to go back to chapter 7 in your packet, and I'll bring it up for you, because that's the place where you're introduced to what the look might be and comparing it to the histogram that we used to have. So I'm bringing back up chapter 7, section 1. And let me share my screen. So if you've got your packet, turn to this page right here, where it talks about normal probability plots, While you're in your packet, thumbing through, why don't you go towards the back of your packet as well, and pull out the page where there's a bunch of calculator instructions. And the one page you'll want to get out so you can follow along would be this one here. So while you're getting your chapter 7, section 1, or flipping there, and to the probability plots that we're going to go through, get this set of instructions that you see here. And then while you're there, a couple pages beyond this page here, there's one table. Might as well grab that one too, because we'll be using it for a while. One table, it's called Table D, which I was messing around with the textbook for a while, but get the Table D one. And so remember, we're doing Daniel LaRose, and I'm using an old edition, 2010. Actually, I'm using a 3rd edition for those of you that are not remembering it, so I think it's even newer than this. This is just a page out of an old edition. So I need you to have access to this table, and I want you to have access to the calculator instructions that look like this. And now I'm going to go back to this page in chapter 7, section 1 for a moment. Because the last problem, I think, that I left you with in part 2 of 8.1 is one that you've got raw data and you don't have sigma given. You've got raw data, and we don't know if it's normal or not, because I think the raw data was only 5 data values. You'll see in a second. But because it's not more than 30, then you couldn't move forward with the normal because it didn't say normal. So we don't know if it's even approximately normal. Probability plots is going to help guide you with that. So detecting normality from a histogram, pretty hard when the data sets are not large. When it says here we view 4 large data sets, it's on the next page, by the way. The basic premise is the plot compares the data with what would be expected of the data that is perfectly normally distributed. Wow, it sounds like a mouthful. Basically, the plot that you're going to see is if it's pretty close to being linear, like a line, the dots kind of line up, then you can just about assume that it's fairly close to being normal, approximately normal. The closer it is to a line, the more normal it is. And the more curvy it is, the less normal, to me, maybe even skewed, and then you wouldn't do it. The data and the idealized normally distributed data, that's what's being compared. If the 2 generally agree, that means the data agrees with what would be expected from a normal distribution. The normal probability plot is then linear. That's what I was saying. Otherwise, the plot would not be a line. Of course, no plot would be exactly a line because you can't connect the dots. They will not be exactly lined up. So we just look for patterns. I'm going to flip the page on this one. So first of all, this isn't exactly symmetric. You got a low one here, got a little high one that's kind of, and you got another, well, this one matches. This one doesn't match. This one matches, this is a little higher. So it's not exactly, but if you look at the dot plot that we're going to learn how to create, it's not exactly aligned, but it's pretty close. Flip the page. Yep, here's another one. Oh, definitely not linear. Meaning that definitely not symmetric. This is a right tail skew that we've talked about in the past. That's definitely not. So you can even see a line right here. The line is created by this must be the program, computer program. Based on information, it creates the line. They call it the line of best fit. That's what the dots should line up on, but they don't. Too curvy. So what you're going to do is you're going to end up saying, I'm looking at the dot plot. When you create the plot, I'm going to look and see how curvy it is. If it's too curvy, and that's just a subjective opinion for now, later on in the course, there's a way to decide whether or not it's too curvy or not, whether or not it's normal. I liken it to, let's see, what was it? The histogram. Sometimes we said, wow, a couple blocks at the end might say that it's the extra data is outliers. And that was just a subjective opinion. But if you remember, we did box and whisker. So if any of the data lied outside the fences, then we say, oh, those are outliers because we created fences. That wasn't as subjective as just looking at the histogram and just looking to see if there's any gaps towards the end. Like this one here, I might say this might be an outlier, but we don't know for sure unless we created like z-scores. Z-scores are anything outside the third standard deviation from left to right. That's how we decided whether it's outlier. So it's just a subjective opinion. Same thing with the curve. How curvy would it be so it's not normal? The ones I would give you on the test, you can tell, you'll be able to tell whether it's fairly normal, like pretty straight, versus pretty curvy. Curvy means can't do it, not normal. And then likewise, this is going to be a left tail. And again, that's kind of curvy-ish. All right, and then we did that one already. So here's our problem in 8.1. So remember, right now, what I want you to have out is, ready to go is the calculator instructions that looks like this, because we're going to go over that to create a dot plot. And I want you to have table D out as well to the side. So the following table, well, let's see, you got 1, 2, 3, 4, 5. So N is 5. Following table talks about 5 nations and its carbon emissions from consumption of fossil fuels. So we got 5 countries. We don't know if the 5 represents normal, and it's definitely less than 30, so I can't even use case 2. It doesn't say normal, so I can't use case 1. But I don't want to completely disregard that it could be normal. We could use the concepts of answering questions about probability or even confidence intervals until we assess the normality of the data. And we're going to use the probability plot. So here's what we do. Get your instructions out like this. Get my calculator out. And we're going to follow my steps that we have. Now, these instructions are also found in your textbook as well in one of the sections, probably section 7.1 as well as maybe 8.1 towards the back, close to the problem sets. Okay, now we say assume the data is in list 1. Well, it's not right now because I haven't put it in list 1. So remember how to do this. It's been a while. Do stat, and then do edit. And I got junk from a while back, got to get rid of. So I want to get the highlighter, that bar right there, up to list one by toggling up. Okay, get that bar up there to list one, toggle up. And then what you do next is you hit clear, but you got to hit clear and then enter. If you hit clear, it won't clear it out. You got to hit clear and then enter, and then it makes it go away. Okay. So now I got to put in the raw data in list one. I can go back to the sheet right here. Here's my data. Okay, I've got the 5 data values. They all look like what I've got down here, so I haven't made a mistake typing it in. So now I go back to my instructions. And yes, the data set's in list one. Now we got to access stat plots. Now remember, I'm doing this based on if it's an 83 plus or 84, 84 plus. If you've got anything beyond this, sorry, you're on your own. You can YouTube it, Google it, try to figure out how to create it with your, say, the Inspire. All right, so we're going to go second Y. So literally, well, if you want to go ahead and get a clear home screen, go second quit, for instance. I think if you just press second Y, it would have gone there directly anyway. So second, and then the Y right here. So you even see it says stat plot, doesn't it? Well, mine does. Y. So right now, all of mine are off. If your has on somewhere, if it says on, then you're okay. If number 2, 3, or 4 says on, then you probably ought to email me and we'll talk about how to turn those suckers off. Right now, I just want plot 1, see stat plot 1, because we'll always use plot number 1. So it's sitting right there, hit enter. Okay, now I'm here at step 3. Okay, what we're gonna do is move the cursor over to on. Okay, the cursor is blinking right now, so it's sitting there. Hit the enter. So I wanna turn it from off to on. Okay, now it's highlighted. Step number 4. Want to select the normal probability plot by moving the cursor to the lower right plot. Okay, so right now, lower right plot is what I want. Right now it's highlighted, mine is highlighted with this one. Don't use that one. These look similar, but they are different. You want the lower right plot. Now here's the thing to get down there. Some of you are going to want to go, toggle down and maybe toggle down. Well, so look at that. It just scooted down. You can't go toggle down, toggle down. You go toggle down, and then even if you hit enter, it'll push you down again. No, actually it didn't. But what you want to do is toggle to the right. Toggle to the right. So I'll do that again. I was up here at plot. I went down, hit on. I'm going toggle down, and now I'm going toggle. Toggle right here. Keep going, keep going, keep going, keep going. That's the one, and I want to hit enter. And then I want to press enter. Okay, that one's highlighted. Okay, data list. I'm going to make sure it's L1. Mine is L1. What if it wasn't? I'll show you how to do that. What if it wasn't? What if it was something like, oh shoot, sorry, gotta go back and do it again. What if it wasn't? Oop, right here. What if it was some weird thing like that, or anything other than L1? What you could do is hit clear. Okay, gone. And look for list 1. Okay, now that's, for me, it's blue. For me, it's number 1. See right there, blue. What if you don't have, see how that's got this A blinking, blinking, blinking? What if yours doesn't have the A blinking, blinking? Then you want to do the, I think it's the alpha, because that's the alpha character. My mistake. You don't want to do alpha. You want to do the second, because mine's blue right here. You want to do second. You want to get to the L1 there. Oh, look at that. It's not right. I don't want A. So I have to clear that out again, and I'll have to hit the second. Okay, second, and now press the 1. Sometimes it's trial and error. Yeah, so I finally got list 1. Eventually, we want data access to the X. Usually it's already highlighted, but just make sure it's X on. And then down here at mark, now I didn't show something here about which mark. All that means is you get to pick. So in your graph plot something, you either pick the little box right down here, or you can pick the crosshairs, or you can pick a very small, highly difficult to see sometimes dot. I don't usually do the crosshairs. I usually do the box or the dots. I'm going to keep it box for right now, and then I'll show you what the dot might look like. So I'm keeping it on mark. And we're about to do step number 7. Let's not do that yet, because something weird is going to happen. Okay, so at this stage, let's pause. So hopefully you've been watching. And I need to show you something that your textbook instructions recommend. And I'm going to show you right now. So pause that. Don't do number 7. Don't do step number 7. I'm going to get out of this by hitting second clear. Second quit. And I want you to go into the catalog. See the catalog down here? You only have to do this once. Just as long as you've done it the once, like today, you never have to do it again. So we just want to make sure something is turned on. Go into the catalog, which should be second blue catalog. And then you're going to get a listing of all these things here, a listing. And so what you want to do is you want to go through and find the letter D. So alphabetical. Scroll, 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 looking for the letter D. And it's called diagnostics. Okay, right there, diagnostics on. So have the little arrow right there on diagnostics on. So I went to second catalog. I went to second catalog. And then I went to alphabetical. And all I did was scrolled. There's another way of getting there, but since D is in the alphabet, you know, kind of on the soon, it's not like Z, where it would take me a while to toggle. But anyway, diagnostics on, hit enter, and hit it one more time. And when it says done, then I'm happy. You don't know what it does, but I'll just say I'm happy. All right, now let's go back so we can end up hitting this zoom 9. We have to go backwards again. So that means we got to go back to stat plot. By the way, this only needed to be done that time. Don't have to do it ever again. So back to stat plot. That's second stat plot. See how it's turned on right now? That's a good thing. Hit enter. Toggle down. Everything's kept the same. Okay, so now I'm down to this mark, which was basically after step 6. I chose my mark. Now I can do zoom 9. So the zoom button is right here. And press the digit 9. If you want to see what it's about, you can do that, but just press the digit 9, it'll always work. Okay, now this is interesting for a couple reasons. You see all the curvy things. That's because I have something in my calculator graphing, as well as, you can see the dots right there, but I have something in my calculator graphing. So if you borrow this calculator and it's not brand new, you need to go into y equals to get rid of all, for me, it's all the curvy things. I'm gonna press y equals. Yep, sure enough, I got something here I was wanting to graph. You need to get rid of anything that's in here. So hit y equals, you got anything here, hit clear, makes it go away, and keep hitting clear if you have anything else beyond that. Clear, 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 clear. All right, let's try this again. I'm going to go back to Zoom 9, Zoom 9, Zoom 9. Okay, and now it's got a decent picture, it's clear. I see the little boxes that I picked, the markers, and I see 1, 2, 3, 4, 5 dots. And what you're looking at is you're trying to see if it's kind of like a line or if it's way too curvy. And that's a hard thing to make a decision on sometimes. There's only 5 dots. It's harder to make a decision with just 5 dots. I'm going to say this kind of looks like a line. They don't all line up, and it's never going to happen. But that kind of looks like a line. Your textbook showed some of the problems with these orange curvy things. We don't have any way of doing it with a graphing calculator. So it's just subjective. You kind of look and say, yeah, it kind of looks normal. It kind of looks like a line. I'll show you examples later on in other sections where you'd say, no, it's way too curvy. So therefore, not normal. Therefore, can't answer any questions. All righty, let's go back to our problem. Now, is it normal? We'd say yes. We'll say approximately normal because we just don't know if it's exactly normal because it didn't line up. Approximately normal. So then we can proceed. We can now to work this problem. Because if it was too curvy, we'd say, even if they were asking you, you couldn't do it. But since it looks approximately normal, we can do something. All right, so he even says, assuming that it's normal, then construct and interpret the 95% confidence interval. So remembering from the previous session 1 and session 2 of this section, what you're using is the x bar minus z sub alpha divided by 2, sigma divided by square root of n. This is the formula before. This is when sigma is given. If sigma is given, less than mu, less than x bar plus z sub alpha divided by 2, sigma divided by square root of n. And you go through and say, what's x bar? You say, oh, well, they don't give it to me, but you can calculate that. You see this? You can calculate that. Aha. And, don't yet, because I'm going to show you in your calculator how to even create the interval notation, particularly for the multiple choice test. It's the calculator keystrokes that are important. But if I were going to try to find that number, you would just go back in. All you do is just add these up and divide by 5. That's pretty simple. Or if you do one var stats with your list, one var stats, it gives you the x bar, and you can check it out yourself. This right here came from your table D. And just to remind you what it looked like, if you're going to plug in that number and say, hey, what's z sub alpha divided by 2 for 95% confidence interval, you would take your table D and you'd find 95, here's your confidence interval. You look all the way down to the bottom, and you'd say 1.960, 1.960, as well as here. Okay, you know n is 5. Okay, sigma. Do we know sigma? Did they tell you sigma? Oh, there it is right there. There it is, there's sigma. So you'd put in 200, 200, and then you'd work it out by hand. Using the calculator from session 1 or 2 that we have just came from. When I say session 1 and 2, I'm talking about part 1 and part 2 of this section. Turn that back on. So using that, I'm getting a clear home screen. What you want is stat, to remind you about this. I'm looking under what's called tests, using the calculator. So stat, right here. I'll scoot over to tests. And the one we used was Z interval because sigma was given. So scroll down there. Now, the difference here from a previous problem, we had used statistics. That means they gave you X bar. But we don't have that. We had to create it. So we can go over to data, toggle over there, hit enter, because I have raw data and it's found in list one. See, it'll draw right from list one. So go to data instead of statistics, toggle down. Okay, sigma was 200, that's what they gave you. We're gonna draw from list one. Always leave it one frequency, always leave it there. And confidence interval, we wanted 95%. Remember that? 95% is right here. So 0.95, hit calculate, and then that answer, okay, remember this is an interval notation with the parentheses, and there's a comma right there. So there's two numbers. I'll write it from the calculator, using the calculator. You have parentheses 386.9, big fat comma, 737.5. Yep, that looks good. And then if I wrote it in interval note, inequality would be 386.9. Units of measurement. I'm looking, it's carbon emissions. It might be particles. It doesn't say, so I'll leave it off for right now. It doesn't say. Oh, it's right here. Million tons, million tons. It's not particles. That's the unit of measurement. Sorry. There you go. Right there. Million tons. And then your statement would be something like, we are 95% confident that the average number of million tons yeah, I don't like that wording, that sometimes I have to change my wording. That the amount of carbon emissions from consumption of fossil fuels, the amount of carbon emissions, I like that better, that the amount in millions of tons is for all nations it's just not for those 5 that we got, but for all nations, is between, I'm going to be able to squeeze this in, 386.9. I'll just round it for right now, 3 because of space. 387 and 738. Remember, that's in millions of tons. So that would be a statement that seems to be reasonable to write. Okay, that's an application that, to me, that's more real life. That's more interesting than the ones where they give it to you. Because this way, you have to kind of interpret it with the raw data that you have. All right, let's see. So with that example, shows you how to input the data and use your calculator to kind of create the confidence interval. I think that gives you enough information to give it a try on your own. So 8.1 is done, and we'll see you again in the next video for section 8.2. All right, take care.